Given 2 points, what we want to do now is find the gradient of the line segment connecting those 2 points. The gradient of a line is a measure of how steep that line is. Now that gradient can be positive or negative, and there are different ways in which you can develop an intuition. That is a way that you can just look at a line segment and tell if the gradient is positive or negative. So one way is just to imagine that this is like a broomstick, and if you place this is a floor, and if you place a broom like that, if it falls to the right, then that's like a line, that segment that has a positive gradient. If the broom will fall to the left, then that's like a line segment that has a negative gradient. Another way is to imagine you have like a little marble here, and if you want to move it from left to right, but if you have to push it, then that gradient is positive, and if it moves from left to right naturally without you having to push it, then the gradient is negative. So we can see that here. For example, if you release this marble, it'll move from left to right as it falls downward. So this gradient then is going to be negative. Here you have to push this marble. It won't move naturally from left to right. So the gradient of this line segment is positive. So looking at these, then it should be easy for you to tell what the gradients of these line segments are. So let's look at this one. This will have a positive gradient. This will have a negative gradient. This will have a positive gradient. This will have a negative gradient. Notice a marble would fall easily. Here the marble would still roll down. So this has a negative gradient. This has a positive gradient. You'd kind of have to push this marble across. A line that's completely horizontal has a 0 gradient. A line that's completely vertical has an undefined gradient. But for now we can simply say the gradient is infinite. Here we have a more formal definition of the gradient. The gradient is defined as the ratio of the change in the y-coordinate to the change in the x-coordinate. In other words, you find the change in the y-coordinate and divide it by the change in the x-coordinate. In some high schools, this is taught as rise over run. So the change in the y-coordinate is the final y value minus the initial y value. So if we start at this point, the final y value, this will be the initial y value, and this will be the final y value. So it's the final y value minus the initial y value. So that's the length of this line segment here. So you need to visualize the little triangle here, and we're going to divide that by the change in the x-coordinate, which is the final x value. So that's 6.57 minus the initial x value, 1.4. Again, you need to visualize this line segment here. So the change in the y will give us this line here. So it'll be 2.92 minus 11.64. Notice I'm saying 2.92 minus 11.64 because I'm taking this point as my final point and this point as my initial point. We could swap that around and say this is the initial and this is the final, but let's work left to right, just so that we all work together in the same way. So note, change is always going to be defined as the final value minus the initial value. So the change in the y-coordinate is going to be the final y value minus the initial y value, and the change in the x-coordinate is going to be the final x value minus the initial x value. So you need to define which of these is initial and which is final, and I recommend that the point that's to the left is going to be our initial, and the point that's to the right will be our final point. So if we complete this, the gradient, and we use the symbol m for gradient, is going to be 2.92 minus 11.64 divided by this, which gives us minus 1.69. Of course, we know intuitively that this line segment has a negative gradient. Note, if we had a little marble here, it would just simply roll to the right, coming down. Let's get a formula for our gradient. So again, we have our 2 points A and B with arbitrary coordinates. We complete our little right triangle, and we state our formal definition. Notice I use these little symbols that look like little triangles. These are actually the Greek letter capital D, and we call them delta. So the gradient is delta y over delta x. Delta simply means change. So this is saying the change in the y divided by the change in the x. And of course, the change in the y is the final value of the y coordinate minus the initial value of the y coordinate. The same thing goes for x. So again, this is something you should be able to remember easily. It's the final value minus the initial value. Assuming that we're making this the final and we have agreed on this. This will be our final point, this will be our initial point. So the gradient is simply the change in the y values divided by the change in the x values, the rise over the run, as some of you were taught in high school. You could also say ya minus yb over xa minus xb, in which case then you'd be making this point your initial point and this point your final point. Okay. So let's look at this example. We need to find the gradient of the line segment connecting the points 7, minus 4 and minus 12, 5. So here is a little sketch. Here is the point minus 12 and up 5, and here is the point across 7 and down 4. So this is minus 12, 5, and over here we have 7 minus 4. So finding the gradient is very easy. It's just the change in the y coordinates divided by the change in the x coordinates. Let's make this our final point. This is our initial point. So it's final minus initial, remember that. So it's the final y value minus 4. What's the initial y value? 5. What's the final x value? 7. What's the initial x value? Minus 12. Be aware of those negative signs. Be careful. So minus 4 minus 5, that gives us minus 9. And 7 minus a negative 12, that's 19. So the gradient then is minus 9 over 19. You could write this in decimal form if you want. That would give us what? Approximately minus 0.47. Okay, so thanks for looking at this video. Bye.